Hey, what's up? It's your old pal, Mr. Cook, and we are working on the first page of the Unit 6C group work. So this is all the stuff on law of sines and law of cosines. So I already worked through the first 6 problems. We're just finding individual parts. Now we're going to work on these next 6 problems, which are solving the entire triangle. Luckily, we've already practiced the steps for finding individual parts. So solving the triangle is actually kind of easy when you practice it enough. So let's draw out our triangles for each of these. ABC, angle A is 83 degrees, BC is 7, AC is going to be 5. And then I'll draw this one as well. So this triangle, ABC, angle B is 97 degrees, AB is 8, and then BC is 14. And for number 9, draw out the triangle, ABC, angle C is 43 degrees, angle A is 55 degrees, and then AB is 20. And then this has a typo on it. This 62 should be a 32, so we can actually do the problem correctly. But we've got a triangle, ABC, BC is 17, AC is 13, and angle B is 32 degrees. And then on the back side, we've got 2 more, so let's do those triangles real quick. ABC, AB is 13, BC is 17, AC is 19, and then the last one, ABC. Angle C is 103 degrees, AB is 7, and then AC is 8. Okay, here we go. So now having drawn all the triangle diagrams, let's assess the situation and solve. So I have an angle, across from it is a side, and then I have another side right next to it. Dang it, so this is the ambiguous case. Let's see if it's 1 triangle or 2 triangles or 3 triangles or 4 or 5. Just kidding. It'll either be 1 or 2 or 0. So let's see what the case is. For 83 degrees, that's an acute angle. The side across from it is larger than the side next to it, so we only have 1 triangle. That's really good. That's a good case. You always want the side across from the angle to be bigger than the side next to it for your given information, because that means you'll have 1 triangle guaranteed. Anyways, so the things that we need to solve for are angle B, angle C, and then also AB. So the one thing that we can solve for right now is angle B, because that's across from the side that we're given. So we can use the law of sines. The sine of 83 over its opposite side 7 is equal to the sine of angle B over its opposite side 5. So then, you use your cross multiplication, and let's see what we end up with. B is equal to, so that'd be, let's see, 5 sine 83 divided by 7, and then sine inverse of that. So I end up with 45.15. All right, wonderful. And then that's this angle measurement here, 45.15. Now I have 2 angles, so to find the third one, I just subtract that from 180. So C is equal to 180 minus 83 minus angle B. So let's see what that's going to be equal to. 180 minus 83 minus that angle I just got. So that's going to be about 51.85 degrees. All right, so I've got all of the angles, and I just need 1 more side. So what I can do is just use the law of sines for this. So I'm going to use the sides that I'm given still, so sine of 83 and 7, and then solve for this missing side. Let's call it x. So I use the sine of the angle C, 51.85 approximately, over x, and then I cross multiply and solve again, and I get my x value. So using my calculator, that's going to be, let's see here, 7 times the sine of the angle that we just got divided by the sine of 83, and we get a side length of 5.55. So there's our last little side there. Okay, and that's it for number 7. Now let's go on to number 8. So number 8, we've got 2 sides and an angle in between the 2 sides. So we can't use the law of sines for this to solve for anything yet, but we can use the law of cosines to solve for this missing side length x. So that's what I'm going to do. X squared is equal to, and then it's going to be 8 squared plus 14 squared minus 2 times 8 times 14 times the cosine of the angle between them, 97. So I type that into my calculator. 8 squared plus 14 squared minus 2 times 8 times 14 times the cosine of 97. And that gives me x squared. So to get x, I just take the square root of that. And I get approximately 16.95. There we go, easy enough. There's my missing side. Now let's get the missing angle measurements. So I just need to find one angle, and I'm going to use the law of sines to find it. So I know what my side length x is now, so I'm going to fill that in here, 16.95. Now I use this angle and this side to find one of my missing angles. I'll find angle A, just for fun. So the sine of A over 14 is equal to the sine of 97 over its opposite side, 16.95. So I cross multiply and solve for A, and what do I get here? So that'd be 14 times the sine of 97 divided by the angle that the side length that I just found. So that gives me that, and then the sine inverse of that is going to be 55.07 degrees. So that gives me angle A, 55.07. Now to find the last angle, C, I'm just going to subtract both of those from 180. So 180 minus 97 minus angle A. And what do I end up with? So 180 minus 97 minus the angle I just found, 27.93 degrees. So 27.93 degrees. And that's my last angle measurement that I needed. So I found them all. All right. Well, let me circle my angles back here too. C and B. There we go. Oops. Oh well. All right, so that's 8 and also 7. Now for number 9. So 9 is pretty easy because I already have 2 of the angles. I can solve for the third one by subtracting from 180. So 180 minus 55 minus 43. And I get 82 on the dot, so 82 degrees there. And then it's just law of sines over and over again. So the sine of 43 over 20. And let's label these sides. We'll call this one x and this one y. So that's going to be equal to the sine of 82 over x. Then if I solve for x in this case, let's see what I get. So that'd be 20 times sine of 82 divided by the sine of 43. So 29.04. There's one side. And then I do the sine of 43 over 20, and that's equal to the sine of 55 over y, and then solve for y. So cross multiply and solve, and I get 20 times the sine of 55 over the sine of 43, and I get 24.02. So there's my other side there. Okay, so that's solving for all the angles and the sides, completing the triangle, and then let's do number 10. So this is another case where we have the ambiguous case, an angle, the side across from it, and the side next to it. And this is actually the worst case scenario because if the side across is smaller than the side next to it and it's an acute angle, this gives us 2 different triangles. So I get a whole nother triangle with the same exact starting stuff. So 32 degrees, 13 for the side, 17 for the other side. And the steps for solving for all the other stuff is pretty much the same. I'm going to walk through those right now. The first thing that we can solve for in this setup is angle A. So that's what I'm going to solve for, angle A. So I use the law of sines. Sine of A over its opposite side, 17, is equal to the sine of 32 over its opposite side, 13. Then when I cross multiply and solve for A, I get the following. So let's see, that's going to be 17 times the sine of 32, and then divide by 13, and then I do the sine inverse of that to get the angle. So it's going to be a 43.87 degree angle. So that gives me this angle A over here, 43.87. So this is where we go through the motions of getting the second triangle, because from this, you can immediately get the second angle A. All you have to do is find the supplement. So this angle A is going to be equal to 180 minus that 43.87 angle that we have. So let's see what we get with that. So 180 minus that angle that we just got, and we get 136.13. So that's the other angle that we get. So we've got these 2 that we can work with. And then from there, we basically have 2 problems that solve themselves. You know, like this one, we have 2 angles. So to find the third one, we subtract from 180. So 180 minus 32 minus that 43.87. And we get 104.13. So let me write it out. 180 minus 32 minus 43.87 is equal to C which is what I just got. And then over here I can do the same thing, 180 minus 32 minus the other angle that I just got, 136.13. That's going to give me the other angle C on the other triangle, because this is like triangle 1, triangle 2, so they'll have different everything else, you know, like all the other parts of it are going to be different other than the given stuff that we already labeled. So the last thing that we need is this missing side. I'll call it x over here and x over here. And to find that, I just use law of sines again. So the sine of 32 over 13 is going to be equal to the sine of 104.13 over x. So just cross multiplying to solve, I get my x value. So let's see here, cross multiplying, I get 13 times the sine of 104.13 divided by the sine of 32. And that gives me my missing side, 23.79. So that'd be that x side. And then the last x side that I have here, I'm going to use the 136.13 to solve for it. So I do sine of 32 over 13. And that's going to be equal to, oh wait, what did I do here? Dang it, why did I write 136.13? I haven't solved for that angle yet, have I? So let's get that angle by itself. So 180 minus 32 minus 136.13. There we go. Made a little mistake there. That's equal to 11.87. That's the angle measurement, because all three of these are supposed to add up to 180. Sorry about that. So then we do sine of 11.87 over its opposite side, x. So again, use cross multiplication to get x by itself. So 13 times the sine of 11.87, and then divide by 13. And that'll give us, oh wait, I'm sorry, and then divide by the sine of 32. I made a mistake there almost. Sine of 32, and then I get my other missing side. So x, the other x on the other triangle is going to be equal to 5.05. And that's the missing side there. This is the toughest scenario. It's only because like you have to do 2 of these, but it's really just kind of busy work. So don't get too confused with it with the law of sines, ambiguous case. The key thing is that you just need to recognize when it happens, and that's when you have an angle, a side across from it, and a side next to it. If that's the case, then you know that you're going to have to see if you have 1 or 2 or 3 triangles, or 1 or 2 or 0 triangles. Like number 12, for example, this is a really easy case because you have an angle, a side across, and a side next to it. So this is the ambiguous case. And this is really nice because the side across is smaller than the side next to it, but the angle's obtuse. So that means that this is not possible to make a triangle. And the reason that that's the case, as outlined in the extra review worksheet and video, it's because since this is obtuse, and this is a side that's smaller than this side, it implies that this angle has to be bigger because this side's bigger and the larger angles across from the larger side. So if this angle is bigger than 103, then they already add up to more than 200 degrees, and that's not possible for a triangle. So that's why you can't do it. Number 11 is super easy. These ones are like one of the easier problems that you can have with solving the triangle. It's just using law of cosines over and over again. The one thing you just got to remember is to solve for the largest angle first, and that'd be angle B because it's across from the largest side. So using the law of cosines, B is going to be equal to cosine inverse of, and then it's going to be 13 squared plus 17 squared minus 19 squared over 2 times 13 times 17. And then we just type it into our calculator and get angle B. So let's see what we got there. So cosine inverse of parentheses 13 squared plus 17 squared minus 19 squared, parentheses, close off the top part, divide by parentheses 2 times 13 times 17. So that's the denominator. And then we get our angle measurement, 77.32 degrees. There we go, that's angle B. Next, find the next largest angle, which would be angle A, because that's across from the next largest side. So A is going to be equal to the cosine inverse of, and then it's going to be the sides around A squared and added together, so 13 squared plus 19 squared minus 17 squared, the side across from it, and then over 2 times 13 times 19. So now that's another one that you just type into your calculator, so cosine inverse of, and then parentheses, the numerator, 13 squared plus 19 squared minus 17 squared, divided by parentheses, so parentheses around the denominator, 2 times 13 times 19. And you get your other angle measurement, which is going to be angle A, 60.80 degrees. And then to find angle C, it's just going to be 180 minus both of those. So minus 77.32 and minus 60.80. Let's see what we get there. So 180 minus 77.32 minus 60.80. And we get 41.88, so 41.88 degrees. That's our last angle. All right, so that's all three of those angles, and that completes all of the solving the triangle stuff. So, you know, if you needed some additional help, check out the extra review if you haven't done that already. And if you still need additional help, make sure that you check out those, worksheets that we practice, because that has a lot of problems on them so that you can practice. All right, that's it for that section, and then we're going to move on to another video on the word problems. All right, so thank you, and move on to the next video.